Hi, my name's Steve Ellis. I'm Head of Generation at Ecotricity, and today we are at Alveston Wind Park. So Alveston Wind Park is on a property owned by a farmer we have a partnership with, who owns quite a lot of land. But we have 3 windmills on here, and the reason we only have 3 is for lots of environmental reasons or technical reasons why we can only put 3 on quite a large area of land. So when we first look at a property on a desktop and we do a design where we fill the whole area with windmills to maximise the amount that we could potentially get in, and then we look at it from an environmental point of view, which gives us buffers of where we can't put windmills because of various reasons. Some of those are, we may have the road where we have to be a certain distance away from the road, or we may have a domestic property where we want to keep a minimum amount away from that. So once you put all of those factors into the design, it trims your area down where potentially you can put windmills. Some of the other studies that we do to determine how many windmills we can put up are bird surveys. So we don't want to put windmills and their blades where birds are going to fly or breeding birds are going to be flying. And we also look at bats. So if areas where bats we know are feeding at dusk and dawn, we don't want to put a windmill up there which is in the way of the bats, so we'll remove that out of our design so that we maintain that feeding zone for the bats and for the birds. Another factor from a time point of view is we need to know what the wind resource is. So we put a monitoring mast up which has anemometers at various heights, and that tells us what the wind speed is doing, what the direction of wind is doing, and how much winds we can gather with our particular windmills once we put the final design in. That also tells us what height we would like to build those to get the maximum amount of wind from them. So putting all those factors together, for this particular site, we ended up with 3. So these are Enercon E70 windmills, each of them potentially generating 2.3 megawatts of power, so 2.3 million watts of power each of them, so 6.9 megawatts in total. That power then goes on to the network and via our substation, which is still on the landowner's property just behind me here as well. So these are 65, 69 meters up in the air, so the wind speed and the wind resource is different up there. And you see behind me the blades are facing quite flat to the wind. When there is no wind, the blades are quite a thin profile. And then the anemometer at the top of the wind turbine, which measures the wind speed and the wind direction, will then determine how much wind speed there is. Once it gets to about 2.5 meters a second with this particular model, the blades will start feathering themselves in to get a fat face against the wind. That then generates the movements of the blades. The only thing that turns the blades is wind. There's no motors up there, there's nothing else that can turn the blades, it's just purely wind. So you may think, if it gets too windy, will they keep on rotating faster and faster? Well, they could do, unless what happens automatically, the blades will start to feather themselves out a little bit, less facing into the wind to maintain that maximum rotation which they're designed at, but not over rotate. In some circumstances, and this is really rare, storms can stop wind turbines because it's too windy, but we have to be really windy for these to stop. In those circumstances, for wind that's consistently too much over a 10-minute period, so not gusts of wind, a 10-minute period of strong wind, the wind turbines will go into storm control. And what they do then is they'll feather themselves out, nothing facing into the wind, and then the rotor itself can actually lock down. Now, I've been here for 10 years with Ecotricity, and I'm only aware of that happening once when I've been here with one of our windmills up in Scotland. Another big factor we have is capacity on the grid. So while these are generating a lot of power, when it goes onto the network, in certain areas of the network, there's only a certain capacity of available generation that can be added to it. If we wanted to put more generation on, we could do, but that can cost quite a lot of money to upgrade the network to allow that additional capacity into it. So that's how we get all the windmills here. So let's go take a look inside. Here we are inside the E70 turbine. So we're coming up some steps and we're about 3 meters up in the air. The reason being is we're standing on top of the transformer, which is below me here. So So it's quite noisy in here with the fans blowing, and it's quite warm in here as well because of the transformer from the heat from it. So the transformer, the heat that gives off, we want to keep that cool, but we also want to maintain temperature, warm or cool, into the nacelle. The nacelle is the bulbous bit on top of the turbine. So the fans blow air through these ducts all the way up to the top to maintain that temperature in its peak performance. So on this panel here, you can see where the wind speed is, what it's doing at the top. On the top of the nacelle, there's an anemometer. The anemometer, the old style ones, are the 3 cups that spin and give the wind speed and also give the wind direction. We've got a slightly different system on here, where it's a laser beam that measures particles of dust over 2 particular areas to work out the speed and also work out the wind direction. For the moment, we're at 3.5 meters a second, quite low wind speed. The blades are turning about 7.8 revolutions per minute. At its peak, this one's designed to spin around about 12 or 14 RPM, and that gives it its peak performance, and that's when it's generating its maximum amount of power. A little bit low wind speed at the moment, so we're only at 30 kilowatts. This particular machine is capable of generating 2,300 kilowatts or 2.3 megawatts. So these are self-sufficient, very intelligent machines. They look after themselves. There's hundreds of monitoring equipment on here, which we can dial into remotely to see how they are performing. Our engineers can visit one of these at least once every 6 months. During that time, they'll happily generate power without any intervention from us. Every 10 minutes, we get data back which tells us how they're performing. So if something goes wrong, if a motor's getting a little bit warm or something's failed, we will get a signal which tells us that, and then we dispatch a team to come and fix the turbine. So the engineers will come out and they'll either be working in this area here or they'll have to climb to the top. The way they get up to the top is via this ladder, which does go all the way to the top. There is an elevator in these as well, which is more of a platform with a winch, which will take the engineers up to the top. The reason we have the elevator in is because if the guys are coming out and they will need to climb 3 or 4 windmills a day, by the time to get to the end one, they're going to be pretty tired, and that's when accidents happen. So we want to keep them in their peak physical performance so they can do the work at the top without being too tired. So that's a little bit about how it works inside. So let's go and have a look at the substation and see where the power goes. So here we are at our substation. The green building here is split up into 2 separate parts, one owned by Electricity, one owned by the network operator, which in this case is Western Power Distribution. So the cables come back to this point here, and this is where everything's metered. So incoming supply or outgoing supply is metered here, and also the communication devices as well. So all the communication and all the control systems that are on the windmills, that data is transmitted via fibre optics to this point here, and then transmitted to our service team so they understand how the windmills are performing. Inside the substation, behind me, is the big transformer. We generate at 11,000 volts from the windmills, through the cables, up to this point here, through the meter, into the transformer, steps it up to 132,000 volts in this case, and then transmits over into Western Power Distribution side, and then on to the network, and then away. So with these 3 windmills at Alveston, we are generating a maximum of 6.9 megawatts of green electricity. And that's owned and operated by Electricity, and that's our own generation. So out of these 3 windmills, in total we've got 6.9 megawatts, 6.9 million watts of power, which is Electricity owned, goes onto the network, and that's what feeds our customers.